In this video, we are going to find the area of the region bounded by x plus y equals 5, y equals 2x, and y equals 0. If you were to graph these functions, you would see that this is the graph of y equals 2x, that this is the graph of x plus y equals 5, otherwise known as y equals 5 minus x. And remember that the graph of y equals 0, this is just the x-axis. So the x-axis, this is this right here, this is y equals 0. You can see why that is real quickly. Remember from previous classes, if you wanted to graph y equals 5, you would go up to y equals 5 and draw that. All right. So naturally y equals 0, that would be at 0, so that is the x-axis. All right, so we're going to find the area of the region bounded by these 3 lines, and so that is exactly this area right here, this area of this triangle. In this video, I'll find the area by integrating along the x-axis, and in the next video, I'll find the area by integrating along the y-axis. And you'll see that integrating along the y-axis is actually easier. Okay. All right, so let's see. X plus y equals 5 crosses the x-axis at 5. And the reason why this integrated along the x-axis is actually harder is because it requires 2 integrals. All right, so, but before we find those 2 integrals, let's first try and do it with 1 integral to see why this doesn't work. All right, so remember, to find the area of this region bounded, right, we would first choose some arbitrary rectangle. And then now we'll find the area of this arbitrary rectangle, dA. All right, so let's see, top minus bottom, that would be topmost function is 2x, bottommost function is 0, y equals 0, and then our width is dx. All right, so now here's the problem, right, is that this only describes rectangles up to this spot right here, right? The topmost function of this rectangle over here is not 2x, right? The topmost function of this one is 5 minus x. So this is why you have to have 2 integrals, because we have 2 topmost functions. All right. So now let's figure out so we're going to need 2 integrals because we have 2 different topmost functions, right? Okay, and then what we need to do is we need to figure out how far to use y equals 2x as the topmost function, meaning using this rectangle, and then when to actually start using this rectangle. And so that place that we're going to actually decide where we use the different rectangles. Let me do this again. There we go. Right, so we'll have 2 different areas. We're going to have this area here that we're going to compute, and we'll have this area here that we're going to compute. And so our area, we're going to start at 0, stop somewhere. Somewhere will be right there. And let's see, the topmost there is 2x, so we have 2x minus 0 dx. Well, 2x minus 0, that's just 2x, right? So we'll write this as just 2x dx. And then we're going to start at question mark and go to 5. And here our topmost function is 5 minus x. So we have 5 minus x dx. And so the real difficulty is finding where do these two graphs cross. Remember, to find where two graphs cross, we set their functions equal to each other. So where do they cross? Let's set them equal to each other. 2x equals 5 minus x. Let's see, adding x to both sides. 3x equals 5, x equals 5/3. So now we know that they cross at 5/3, and we're going to integrate from 0 to 5/3. And from 5/3 to 5. And that will give us the area of that region. All right, so finding that area, let's see, we've got x squared over 2, otherwise known as x squared, right, because we're going to have 2 and then 2 there, so 2x squared over 2. Getting rid of canceling those 2's, we've got x squared from 0 to 5/3 plus 5 minus x. Let's see, we got 5x minus x squared over 2 from 5/3 to 5. All right, so we got 5/3 squared minus 0 squared plus, let's see, we've got 5 times 5 minus 5 squared over 2 minus 5 times 5/3 minus, let's pull that half out front, 5/3 squared. Let's see, I'd say 5/3 squared minus 0 squared, and then we got the 5 in there, and then 5 squared over 2 minus 5 times 5/3 minus 1/2 of 5/3 squared. Okay, I think I did all that right. Okay, so 5/3 squared. Now notice there is like another 5/3 squared. There's a 5/3 squared here and a 5/3 squared there, which is a half. So I'm not going to change anything with those just yet. So I'll write this as 5/3 squared, let's see, plus 25 minus 25 over 2 minus 25 over 3 plus 1/2 5/3 squared. Okay. Now just arithmetic. All right, so here, right, we've got 5/3 squared and we've got a 1/2 5/3 squared. So they're really just like terms. You can think of the 5/3 squared as like some variable. We're combining like terms. 1 plus a 1/2 is 3/2. So we have 3/2 times 5/3 squared. 3/2 times 5/3 squared. Let's see, that'd be 25 over 9. So we got 3 there. See, that'll be 25 over 6. Okay. Plus 25. 25 minus 25 over 2. Again, you can think of the 25 as like a like term, or is like term. So 1 minus a 1/2 is a 1/2. So this would be 1/2 of 25, or 25 over 2 minus my 25 over 3. So here I've got 25 over 6 plus 25 over 2 minus 25 over 3. I'm going to think of this, I'll factor out the 25 and think of this as 1/6 plus 1/2 minus 1/3. Let's see, 1/6 plus, let's see, 2 times 3 times 3 times 2 times 2 plus 3 over 6, that's a 1/2. Yeah, that works, okay. And it was a minus, huh? Minus 2 over 6. So you got 25 times, let's see, you got, put the 6 in the denominator there. So 3 minus 2 is 1. 1 plus 1 is 2. So like that. A third. So we have 25 thirds.